everyone, welcome to the Educational Channel and this is Srinan. So today we are going to be in the same topic, coordinate geometry, but this is a new thing, triangles. This is not the concept you are thinking about. It's not about classification of triangles based on angles or sides. It's about finding the areas of the triangles by using the coordinates of all the three vertices of a triangle. Okay, let's get started. So first, if you have a triangle and you are asked to find out the area, what do you have? You exactly do not get a perfect triangle always, right? This time, you are getting something else, like a triangle is there. The sides are different, 3, 4 or 5 or else 6, 7 or 8, any 3 numbers, and you are asked to find out the area of the triangle. Okay, so there are many methods, of which I am going to tell you 2 methods. So first, we have read about this formula, right? This formula. If you have 3 sides, A, B and C, and you are asked to find out the area of the triangle, then your formula will be square root of S into S minus A into S minus B into S minus C, right? Where S is equal to A plus B plus C all divided by 2. This is the formula, right? So for this, what do you need? All the 3 side lengths and then the S value, you can compute them easily. That's it. Now, if I give you a triangle like this and I'm asking you to find out the area of this triangle, what are you going to do? If you really want to apply this formula, then it's a very lengthy process, right? You have to find out these 3 side lengths and then you have to take the S value of the side lengths, take a square root and then find out the value. It's very long, right? Time-taking process. And in a few cases, you will get irrational sides, right? Irrational sides because you are using the distance formula which has a square root in it. So you will have irrational sides also. Anything is possible. So for a safer side, if you use this formula, the actual formula for finding out if you have the vertices coordinates in this case. Okay, let's start. I want to find out the area of this triangle. Okay, I'm gonna call this as A, this as B, and this is C. Okay, very simple. Now I'm gonna call it A as X. This is X1, Y1, and then this is X2, Y2. This is X3 and Y3. Okay, I have labeled them. Now what is the formula? Very simple. The formula is half of modulus of this. Just a minute. Okay, this is a modulus sign and this is a modulus sign. What lies if you exclude these modulus signs? There's some kind of 11, right? Bars. They are called determinants. This is called a determinant, modulus determinant. Then how to find out the value of area of triangle? Very simple. First we will substitute the values and then I will tell you how to solve this. Very simple. So, which is equal to half of x1 minus x2. x1, right? x2, 2 minus 2, 0, right? y1 minus y2. y1, y2, 4 minus 2, 2. Now, x1, x3. 2 minus 4, which is minus 2. And y1 minus y3. 4 minus 2, which is 2. Over. That's it. Now we are going to carry over the same half here. Now what we are going to do is, we should not ignore this modular sign. Sorry. Now what we are going to do is multiply first this side. From this side you have to go like this. You are going to climb up. Okay, from the right side. 2 into 0, 0. Okay. Now automatically a minus will come here. Automatically. And then this you have to multiply. Okay. 2 into minus 2, minus 4. Already you have minus sign. I am going to put another minus 4. Put it, and then again a modulus sign. Because the area cannot be negative. Area of any shape cannot be negative. Half of 0 minus of minus. Minus of minus becomes plus. So you have a positive sign. Remove the modulus because you have a positive one. And half of 4, which is 2. 2 units. 2 square units is the area of this triangle. And I'll call it as 1. Okay. AR means area of triangle 1 is equal to 2. Okay. Similarly, we are going to find out this and this. Very simple. Again, we will move on. Okay. This is 2 and this is 3. Okay. Now the same formula, half of. But before going into that, I will just give you another practice example for determinants. We have to solve them, right? Okay, that's it. Now, sorry, 1 minute. I have this determinant. What is the value? First, from right to left, you are going to climb up. 1 into 1, 1. Automatical minus. And then 2 into 0, 0. That's it. First this side and then automatic minus, next this side. Better you put a bracket after that automatic minus so that you don't get any sign confusion. Okay. So the second one, half of. Half of. I am writing here so that you can see. Half of x1 minus x2, or else I will write the formula here separately so that we can refer easily. Okay. Now half of x1 minus x2. Again here we are going to call them no need of ABC, right? Anyway, they are not useful. So, they are not useful, ABC are not useful. Just for this first case, I didn't like that. Now, x1, y1, x2, or else I will write this side so that you can see, okay? x2, y2, x3, y3, okay? Now let's start the same thing. Half of x1 minus x2 minus 2, okay? x1 minus 3 minus x2 y1 minus positive 1, right? So it's the same. Now it's this part is over. We will go here. x1 minus x3 minus 2 minus of minus 2, okay? Now y1 minus y3 4 minus 2. That's it. Very simple. The same procedure. Minus 2 plus 3. Minus and minus. It will become plus, right? 3 minus 2 is 1. Minus 2 minus of minus 2. It will become plus. Plus 2 minus 2 is 0. 4 minus 3. 4 minus 2, 2. That's it. The same thing. Half of modulus of. Here I did not include the modulus sign because usually you will get a positive value. Even if you get a negative value, you're gonna use your common sense and make it positive, right? Just change the sign. So hereafter you will not be needing this modulus sign again and again for the calculations. Okay. Again here 2 into 1, 2, automatic minus 3 into 0. Half of 2. Half of 2 is 1. That's it. So area of triangle 2 is equal to 1. Okay. The same way you can try the third one. If you want to try it by your own, pause the video. Okay. Now for the third one, and then we will move on to a new topic which will be useful in our triangles concept also. Okay. Now the last one, we have to do it quicker, okay? So half of x1 minus x2. y1, again labeling it because you should not make mistakes in the substitution part. x2, y2, x3, y3. I can interchange them, but only on a duo basis. x3, y3 must be here, x2, y2 must be here. Both of them should be here, but if I change even one of them, the answer goes wrong. Half of x1 minus x2. y1 minus y2 minus 6, right? x1 minus x3, 3 minus 5. y1 minus 6. Same. Now what we have to do? Half of simplify it. Okay. 3 minus 5 minus 2. Plus, right? Plus 6 minus 3, 3. 6 minus 3, 3. Half of 3 into 1, 3. Automatic minus. Minus 6 over minus and minus plus. 3 plus 6, 9. So 9 by 2 is 4.5. So area of triangle 3, 4.5. Okay, got it? Now we are going to move on to the next topic, but first I would like to conclude this. If you have a triangle and the area turns out to be 0, what do you call it? When will the area of triangle be 0? Of course, here I have 3 points. 3 points, okay? If I join them, I get a triangle. A triangle should have 3 points, right? Now, I have 3 points, but they are on the same line. I have one here, one here, one here. Do they form a triangle? No, of course not. So these points are called collinear points.